All right. Hello and welcome everybody. My name is Magnus Jansson and I'm the Market Communications Manager at Westermo. Before I hand over the presentation to our experts, I would like to give you a brief introduction to Westermo as well as sorting out a few housekeeping rules. Westermo is a Swedish company that designs and manufactures data communication products for mission-critical systems in physically demanding environments. Our products are used both in social infrastructure such as transport, water and energy supplies, as well as in process industries such as mining and petrochemical. We have been in the business since 1975, and as a manufacturer of industrial data, communication devices and software, we have gained a lot of knowledge within the company over the years. And today's webinar is an example of what we do to get some of that knowledge out there to you. We develop and manufacture our products in our facilities in Sweden, and we have our own sales and support offices in 12 countries. We also have distribution partners in some 35 countries around the world. So we have a good global coverage, which is important as we know that a local presence is crucial for many of our customers. More information about the company and our product range can be found on the website, so make sure to visit westermo.com if you want to know more. Today's webinar is the third and last session in a series where we are looking closer at the fundamentals of cybersecurity in industrial networks. Today's topic is spoofing protection and perimeter protection, where you will learn more about how to defend your industrial network from unauthorized devices and requests. To present this topic, you will have Niklas Mört, who is the Cybersecurity Product Manager at Westermo, and Jon-Olof Watten, who is one of our experts with the Westermo Network Applications team, both with deep knowledge and long experience of industrial data communication technologies. I will hand over to Niklas and Jon-Olof in a bit. But before I do that, I just want to mention that we are accepting questions, but we will answer them in an email after the webinar is completed. There are many people in the webinar today, and we want to be as effective as possible. If you have any questions during the webinar, please use the chat window and post it to host. I will then make sure that your question gets to Niklas and Jon-Olof afterward. So please type any questions in the chat window and make sure it is addressed to host. I also want to mention that you will get a link to a recorded version of this webinar as well as access to the slides if you want to repeat anything, but more on that in the summary. It is now time to hand over to Niklas and Jon-Olof, so please, the presentation is yours.
Thank you, Magnus. Niklas speaking here, and I would like to wish you all a very warm welcome to this seminar about spoofing protection and perimeter protection. There you go. But before we dive into the nitty-gritty details, and hand over to Jon-Olof, I will just broaden the picture a bit and talk a little bit about the security posture that you need when you work with cybersecurity. A posture or your stance. You can think of it like a boxer perhaps. So you're ready to face the challenges. Usually we talk about I usually take it in three steps. We talk about the protect part, the detect part, and the respond part. They all play a vital part in your cybersecurity defense. And as previously mentioned in an earlier webinar, the protect part is a lot about technology. And what we discussed today, it's about network-to-network protection that we had in an earlier webinar, and so on, with segregation and segmentation of your network, and also today's topics about spoofing protection and perimeter protection. But after that, even if you have installed this, you have your firewall in place and so on, you also need to work constantly. And then it's when the detect part comes into play. You need to monitor your network. Do you have intrusion detection in place and so on? But also, if you detect something in your network, is it a threat, is it an intrusion, Then you also need to have a response, an incident response plan. You need to contain the breach and so on, have a security incident response team ready. And this will also feed back into the protect part. How can you change the rules in your firewall, for example, and so on. But today we're going to focus on the protect part, as we have done in the previous series as well. And then, of course, mostly about spoofing protection and parameter protection. And before I hand over to you, Olof, I want to just take a look at the purpose or the why. Why would you use spoofing protection or perimeter protection? Obviously, one is that the threat of rogue machines, someone connecting a laptop or anything else just into an open port and so on. And we will show how you can defend against that. But also the threat of unauthorized and malicious traffic, of course. You can keep control, you can whitelist what traffic is allowed. But that also means that you can do this in both directions, not only inbound. That's the normal way you think about it when you install a firewall, that you block incoming requests. But you can also monitor and look for the outgoing connections. So you can stop that. If you have an infected computer that wants to open a connection, an outbound connection, that you can stop that. And last, I could mention logging, which is something that you maybe sometimes don't think about, which is a very important part of, say, a firewall. It's the logging, because that's where you go. If you have an incident or a breach, you need to be able to look at the logs to see what actually happened. So these are just few. There are more purposes as well when it comes to spoofing protection and perimeter protection. But now it's time to jump into the details about this. So I'll hand over to you, Olof.
Okay, thank you, Niklas, and welcome once again. So Niklas mentioned a bit the purpose and why we are looking at this. I will now look more how we do this. And the outline here is, first I will present two of the features we have: port network access control and demilitarized zones, and after that some use case examples. So regarding port network access control, that concerns limiting unauthorized access to your local Ethernet port. So this is a kind of local attack, and that addresses both spoofing and some kind of local perimeter protection. And demilitarized zones, that is more from external attacks. Someone would like to attack you from the internet. Okay, so here we go, starting with the functionality. Port Network Access Control, or PNAC as it's an acronym. What is this about? As I mentioned, it's about protecting against unauthorized network access via your local area network ports. So this is what we call a local attack. The attacker needs to have some kind of physical presence at your vicinity. So it attacks the lead networks or access networks where someone would like to hook into your infrastructure. And the objective could be to get access to your local resources, your different assets in your local network, but it could also be different kind of spoofing attacks to other parts of your local network or to the outside. And it doesn't really have to be an attack either. It could be unintended misuse, but that is also a problem if you have critical, mission critical networks here that or processes that you are supporting. So what is the main problem here? Are your local LAN ports really exposed? And looking at your access networks, you have access switches, and you should start with physical security. Make sure that these switches are not exposed. You can lock them in a locked cabinet, and the cabinet can then be in a locked wiring closet, so no one should have unauthorized access to these facilities. But of course, you also have RJ45 sockets out in your office where people could connect if they are connected to your network. So that is something we need to protect somehow. The situation would be similar for wireless access, or even worse then, because then you cannot really physically block users from accessing your network because the medium is shared. We'll not cover wireless access further in this presentation, but the techniques to solve it is similar to doing it with these public RJ45 wall sockets. Before we dive into the different solutions here, we will distinguish then your different kind of ports, how you should solve it. And the ports that you're actively using could either be trusted ports, which connects your local equipment, which could be locked into the wiring closet. But it could also be inter-switch infrastructure ports, which are also hidden, or you have physical security, so no one could really tamper those ports or connect to those ports. In that case, you may not need to do anything extra here to protect them. Perhaps add a link alarm just to make sure no one really disconnects and connects some other equipment, perhaps. Another thing are ports that are really exposed to the access network, ports that are really connected to wall sockets or public areas. In that case, you should have port network access control, which we'll present a bit further in the upcoming slides. You can also activate link alarm just to detect if someone connects or disconnects a port. So you could take action or be able to log and see what happened if in case you have some kind of attack. Unused ports, for example on this switch, they should either be disabled or you should skip connecting them to a public area, to the wall sockets in public areas, thereby avoiding that someone connects to them. Okay, so if you have your untrusted ports, what do you do then? Let's say you have wall sockets where someone could connect, but before gaining access to your infrastructure, your network, they should be, the devices or users should first authenticate themselves. Historically, there had been a lot of different inventive solutions, for example, based on web portals for login. So you have some kind of limited access. You could access a web portal, you could fill out your username and password, and then log in and gain access to the network. There are also simpler variants where you know beforehand a set of MAC addresses of the units you would like to have access, so those are allowed to pass while others are blocked. That would be some kind of MAC authentication, no cryptography, but good still for some basic or limited security. In parallel with this, there were standard solutions developed by IEEE, and the two major standards here are one called 802.1x, used for authentication and authorization before you gain access to the network, and this is done at layer 2. What I mean with that is all authentication and authorization is done by sending packets over the Ethernet. You don't really need an IP address beforehand, which could be a problem then if you don't have access. So 802.1x is something we'll discuss further in the upcoming slides. IEEE has also defined another standard called MACsec, which not only allows you to get network access, but will also protect the link on the traffic between the end device and the first switch. So that would both encrypt and integrity protect that data. WeOS devices have support for 802.1x and also MACsec, so we'll discuss these further on. We don't MAC authentication we have support for. However, MACsec is not available in our products yet, but we'll come back to that as soon as we have support for it. So how do we then do? In this case, you can have a look at the page. The end devices where you have where you have the proper credentials, they would get access to the switch ports, while unused ports or ports where you have someone not being able to show adequate credentials, they will be blocked. That is the idea. So if we look at 802.1x, how do they do it? You first have some terminology. The clients, they are called supplicants. The unit blocking or controlling who can access the network or not are called authenticators. In our case, that would be the WIOS switches. And there is also a backend authentication server, typically a radio server. And then in a nutshell, the authenticator, the switch here, will block access ports by default, so no traffic is allowed to pass. However, it will allow the authentication handshake to pass. So the authenticator will relay the authentication handshake between the client or the supplicant and the authentication server. And if the handshake goes well, if there's success, then the authenticator will open up the port for that specific user. So the MAC address is then allowed to pass through. And it can be with periodic re-authentication, so the end device will have to authenticate perhaps after an hour or so, or 10 minutes, you can control that. But that should be no problem, because all of this should be in software. You don't really your communication authentication. Then WIOS switches, they can act as 802.1x authenticators with a radius backend. Some of the details on the background how 802.1x works regarding security. As I mentioned before, there is an authentication handshake done between the supplicant, the end device who wish to connect, and the backend radio server. And the role of the intermediate authenticator is just to relay this handshake. So we would start with the supplicant connecting. It will be requested to tell who he or she is, responds with its identity, and that is forwarded to the radio server. And then you initiate the real authentication handshake, and there are different protocols for this. For example, something called EAP TLS, something called PEAP, protected EAP, and others, but these are probably the most popular ones. These two protocols, these examples, EAP TLS and PEAP, are both based on TLS, which is used, for example, in secure web communication, HTTPS. So what happens is that you first create a secure tunnel between the supplicant and the radio server through the authenticator. And the server will, as part of establishing this TLS tunnel, authenticate itself with a certificate. So the client knows it talks to the correct server. Then there can be different ways, but in PEAP, the client uses regular password and username, which it will then send through the TLS tunnel with the handshake. So the client in that case would authenticate itself by regular username and password credentials. There are alternatives, like in EAP TLS, the client would also provide a certificate to authenticate itself. So in either case, in both of these cases, the client needs to be configured with some kind of credentials, and also the certificate of the certificate authority that has given, in order to be able to know it talks to the right radio server, it needs an additional CA certificate to verify that it's talking to the right server. All of these configuration, your IT department should be able to help you with when you set up 802.1x. What is important when you configure the WEOS switch, the authenticator, that is the protection of the traffic between the radius traffic between the authenticator and the radius server. And for that, when you use radius, there is a shared secret shared between the authenticator and the radius server, protecting the traffic. This traffic commonly is sent over a local infrastructure, but if you want to have additional security, you could always complement this with using a VPN. We have presented that in an earlier webinar, the first one in this series on network-to-network protection. So please go back to that and see how you can set up, for example, an open VPN tunnel between the authenticator and the radius server. So if you would like to configure this on a WEOS device, primarily it would be defining the radius server. That's the first thing. In the web, you would do this in the configuration under AAA and remote server. And the information you need to add is the domain name or the IP address of your radius server, and then also enter the shared secret between you and the radius server, between the authenticator, between the WEOS switch and the radius server. Of course, you could also add, as I mentioned, an optional VPN tunnel to secure the traffic. So you can actually have backup radius servers, but in this case, we just have an individual server. But if you have backup servers, you can then form a group and use this radius server group when configuring the remaining parts of 802.1x. So the next step is to define a AAA instance for 802.1x. And in this case, we just select the server, radius server that we just created. There are also other 802.1x specific settings, for example, the re-authentication interval, if you would like to change that. And once you have this, you have to connect this AAA instance for 802.1x to the ports that need to be protected. So which ports are exposed in your wall sockets, or which one would you like to protect with 802.1x? In WEOS, you go in under configuration, VLAN, and port access, and you select the VLAN where your ports reside. So what happens then is, if you select, in this case, for example, VLAN 1, all ports on VLAN 1 will then be subject to 802.1x protection, unless they have tagged traffic, or if you decide to exclude them. In this example, I have excluded port 10 because that is the port going to my radius server. So when ready, you select your AAA instance here, which we just created, and any port to be excluded, and you click apply. If you would like to read more about this, how you do it on WEOS devices, there is a dedicated application note. You find the application notes at the Westermo website, looking under support and application support. And this specific application note is called WEOS Port Security. There's also information, of course, in the WEOS management guide attached in your release zip. If you would like to protect somehow devices that do not support MAC authentication, 802.1x, you could use MAC authentication for these kind of legacy products. That means you also block traffic by default, but you allow certain MAC addresses. So you can create a list of MAC addresses that are allowed to access. This prohibits accidental misuse, but there is no cryptography, there is no kind of credentials by the end devices. So it doesn't really stop a dedicated attacker, but it's still good to give some protection when you are using legacy client equipment. If you think it's cumbersome to really know what kind of MAC addresses your different end equipment have, we recommend using the weakconfig tool from Westermo, because it really provides an easy way of configuring MAC authentication. So now we have discussed the different features of port network access control. The next feature or next topic would be demilitarized zones. And with demilitarized zones, we more talk about firewalls, how you can use them to protect traffic between an external network and an internal network. And in the internal network, you have assets you would like to protect. What demilitarized zone helps you with is if you have some resources that you would like to be available both from the external network and from the internal network. So one example would be if you have some kind of company email and web server which you would like to have accessible from both the inside and the outside, but you don't want any traffic to go through between the in and out. So they can both access the DMZ, but that's it. Another example would be if you have a manager who wishes to access production data gathered from your operations network, but don't wish to open up security holes, you could put some kind of data store in your DMZ. So you provide access to this DMZ, this data storage from the external network, that would in this case be an office network, and also from the internal network where you can upload process data. Then to really how you can build your DMZ, there are two types of DMZs. One is where you use a single firewall. In this case, this firewall needs at least 3 interfaces, one for the external network, another interface for the internal network, and a third interface would be to the DMZ. And this is something you can build with a WEOS device running software level extended. Another type of DMZ can be built with a dual firewall solution. In this case, you would have a front-end firewall and a back-end firewall. And the front-end firewall would then be the interface to the external network. And the back-end firewall would be the interface protecting the internal network. And the DMZ would be in between them. Sometimes I call these front-end firewall also the perimeter firewall or the IT firewall, while the back-end firewall could be called the internal firewall or the OT firewall, since it's more an operations technology behind that it's protecting. In this case, one of the benefits with using a dual firewall solution is you can have different vendors for the different firewalls, and that is providing some extra security. You could use the WEOS firewall as the backend firewall. It's really an industrial product, so it suits well for protecting the OT network. And you could have some other vendor as a front-end firewall. Now, looking at some use case examples, we continue with the DMZ, the demilitarized zone. Here's an example where you would like to create a single firewall DMZ with a WEOS device. As I mentioned, you need 3 interfaces. Here, first start with some IP planning and segmentation. So we have segmented the network in 3 different virtual LANs, VLANs, and each VLAN has a network interface with a subnet. Could be of your choice. In this case, it's private addresses 192.168.1.0/24 for the internal network, and so on. So creating the VLANs, yes, you would go in the web, you would go to configuration VLANs, and create a new VLAN. In this case, we create the third VLAN, that is for the DMZ. You fill out which port should be there, and you click apply. And what you need in the end is, in this case, 3 different VLANs. Here it's VLAN 1, VLAN 2, and VLAN 3. What you do next is, you assign IP addresses to the router interfaces. Here it's for the DMZ interface. I have given it address 192.168.3.1. I have also disabled management services here. Don't need that from the DMZ to control the firewall. But to sum up, here we have 3 different interfaces, and each of them has an IP address. That is what you do in IP configuration. If you would like to look more at how to do it, I ask you to go and listen to the previous seminar on network segmentation and segregation. We go through this in more detail there. Similar, what we did then is for the firewall, when you have done IP configuration, you have connectivity. Now we would like to limit who can talk to who. We do that by enabling the WIOS firewall, or you could also have a NAT wall. Here it's just a simple firewall. When you enable the firewall, the default is to drop all traffic. So no traffic will be allowed to pass through. So that's good. But what we had to do then is to whitelist and forwarding allow rules for the traffic that should be allowed to pass. And what we have done is being able to upload, for example, traffic from your local network to the DMZ. You should have an allow rule for external traffic to the DMZ, and try to make this as specific or limited as possible, so you don't open up more than necessary. In this case, we have a rule from external side to the DMZ. Traffic coming in on VLAN 2 is allowed to go out on VLAN 3, and to limit it even further, it's TCP traffic from a specific source, and the protocol is HTTPS, and to a specific address. So in this case, the manager, if they would like to access some process data, they could access it with HTTPS from a specific source address in the external network to a specific address in your DMZ where the server is hosted. So this was from external to DMZ. You should have a similar rule from internal to DMZ to upload your process data. If you look in the list of filtering rules, you should then create, it should show 2 rules. One is the one I just created here, from the external to the DMZ. The other rule would be for uploading, that is in this case from the local network, the internal network, and in this case it allows Modbus TCP traffic to go from a specific address in your internal network to the DMZ. And there is no other traffic allowed to pass through this firewall. External can access the DMZ, internal can access the DMZ, but no traffic can go directly between the external and internal networks. Also, I could mention if this device is then put to the internet, or if you like to protect this interface to the external network a bit further, we should do some more hardening. Of course, you should change your default password. That you should always do. It goes without saying. In WEOS, there's also some implicit connections through the firewall to really manage the product. In this case, the firewall itself. And to disable that, you go into configuration, network interface for the wide area network interface, the external interface here it's VLAN 2, and you disable the management services. Thereby, you cannot from the outside connect with HTTP, SSH, and so on. Also, as devices could be used for both as DHCP servers and also as DNS forwarders, on the upper interface, the WAN interface, you could add firewall rules in the firewall to prohibit any requests for DNS that way. But you could also just go in and disable the domain proxy service. So you do that by in the web in configuration, network, and domain proxy, and you disable domain proxy. Thereby, you don't get exposed to relay DNS messages. And in general, that is, you should disable services that you are not really using. Okay, another use case then, that would be more for securing your access switches. In this case, it could be access switches at your local premises. We have discussed this earlier, the feature with 1X and port network access control. What you should do here is, first you should look at physical security, make sure the switches are in locked cabinets, and you can even make sure that you detect if someone tries to open a cabinet. You should have some kind of door alarm. And the WEOS devices actually have features for that, so you could connect the door to the status relay and have an alarm set for that. So as soon as someone opens the door to the cabinet, you could be notified in your management system and take actions. To secure port access, you should, as we mentioned before, disable unused ports and ports that you are using and that are considered untrusted. You should protect with 802.1x with the radius backend, as we showed in earlier pages. Of course, we should always try to limit your access ports. So if someone is able to break in, they shouldn't get access to the whole network. So make sure you segment your network properly. And if it is a firewall, you should also do network segregation, as discussed in previous seminar and also on the previous pages. Also, be able to log what's happening, for example, link up and link down events, login attempts, and also traffic that gets through the firewall can be logged. So enable firewall logging as well, so you are able to react if something happens, or being able to analyze what has happened if there has been an attack. So this is what you can do for your switches at your local premises. If you have switches located at some kind of remote premises, the same recommendations apply. But in addition to that, these switches could be connected directly to an external network like the internet, if you would like to have remote access to them. So there you should also enable the firewall and do the kind of configurations we did in the previous pages for a perimeter firewall. Also, in order to allow for remote access, we should configure VPN. And for that, I recommend you to go back to the seminar on network protection and see how you can configure VPN like OpenVPN for WEOS devices. Then to sum up, we have shown different features here regarding spoofing protection, handling attacks from the local premises, and primarily we looked at network port access control by use of 802.1x with the radius backend. Perimeter protection as well, attacks from the internet, where you could use demilitarized zones to allow access to certain facilities or servers, but prohibiting access between an external and internal network. You could do it with a dual firewall solution with a front and back end, or with a single firewall solution. And for more on this, how to configure firewalls, I recommend you to go back to the previous seminar on network segmentation and segregation. We looked at 2 use cases. One is for how to create DMZs using WIOS products, and the other one is doing network access with 802.1x using WIOS products. That sums up my part on how. I will hand back the word to Niklas.
Thank you, J.O. Before I really leave you all, I will just do a bit of a recap about your security posture and what we have covered in all these seminars. First of all, we started at the top level. We discussed this, that you need to work with the protect, detect, and respond parts, and it's a circle, that it's a continuous work. You're really never finished, but you take small steps all the time, and we've discussed and talked a lot about the protect part, network to network protection, the VPN, and so on, but that you also need to start working in other areas, because that will, when you do, say, threat modeling, you will also find new ways to apply rules to your firewalls and so on. So it's very important to start working in the full circle when it comes to cybersecurity and your security posture. And in the webinar series, we have covered different parts in the protect. Today we talked about perimeter protection and your demilitarized zones and the various types of how you can set that up with a single firewall or a dual firewall, so on. And after that, in the previous one, we have talked about network segmentation, or VLANs, which is a good way to segment your network to prohibit access to certain devices or servers. We also talked about segregation. It was another way of applying the firewall. In this case, you see that it's protecting very sensitive data, and you could probably have very limited access to these servers, giving it even more protection. We have also talked about spoofing protection today, or for authentication, so that you really don't have these rogue devices connecting to your network. So you have full control of the assets of your baseline. And also in the first webinar that we had, we talked about network to network protection, or VPN. So you can stop that man-in-the-middle attack or someone listening in or securing data in transit. So that sums up all the different parts that you can add to your, say, cybersecurity toolbox to apply to your network and network solutions. As always, there will be differences between every solution or every case. And just the last question that I have, how do you become 100% secure? I guess that would be the silver bullet in cybersecurity. Unfortunately, as this guy really explains, that he actually says that they are 100% secure now, but he did that by turning them all off, and that's unfortunately the only way to be 100% secure. So it's a continuous work, but in this series we have given you a few tips that you can use and start with when working on your cybersecurity posture. And with all that, I would like to say thank you for listening in, and I hope it was worthwhile and that we could give you some new input. And with that, I hand over to you, Magnus, for some final words.
All right. Thank you so much, Niklas and you, for this webinar. But before we just say goodbye, I just want to mention what happened next. So this was the third and last webinar in a series of webinars where we have been discussing the fundamentals of industrial cybersecurity, as well as how to use Westermo networking products and the WIOS operating system to help you achieve a sustainable security posture. You can find the previous webinars on network-to-network protection and perimeter protection on the website, and today's webinar will be available on the website in short as well. All webinars are available without the need to register or log in, just a simple click and play procedure. The PowerPoint slides are also available if you should need it. And finally, I just want to inform you about the email I will send you in short. It will include a playback recording link if you want to repeat anything from today's session. This email will also include information on how to contact your local Westermo dealer if you have any further questions, or if you want to start a discussion on how you can use Westermo products to cover your cybersecurity needs. I will also inform you about coming webinars on industrial networking and cybersecurity going forward. And with that, I wish to thank you for joining in today. I hope you found this webinar useful, and good luck to you in your cybersecurity work. We are here to help you if you need it. So with that, thank you and goodbye.